This presentation is about activity 2, generate a pulse width modulating signal presented by Panasonic.
For the discussion, this first waveform is the modulating signal. The square waveform is the carrier signal or the sampling waveform, and the last waveform is about the pulse width modulated output. So, pulse width modulation, also known as PWM, is a commonly used control technique that generates analog signals from digital devices such as microcontrollers. The signal thus produced will have a train of pulses, and these pulses will be in the form of square waves. Thus, of any given time, the wave will either be high or low. Pulse width modulation reduces the average power delivered by an electrical signal by converting the signal into discrete parts. In the PWM technique, the signal's energy is distributed through a series of pulses rather than a continuous varying signal or analog signal. So in this slide, it shows the pulse width modulated signal circuit that we use. When on testing the circuit shown earlier, the square wave generator output uh, creates a sawtooth signal as shown on these images. And this is the waveform of the sine wave generator. So it's flat because the amplitude of the sine wave is at 0. So it looks like a DC signal. And this is the pulse width modulated signal output. For the activity result on the pulse width modulation circuit, the blue waveform shows the output of the pulse width modulation circuit. The green waveform is the sine wave generated by the sine wave generator, and the light blue waveform is the square wave. So it looks like a sawtooth with little square waves on both ends, and the output of the PWM follows the waveform, the square wave waveform. The duty cycle of the PWM is 50%, and as I have observed, the PWM type of the output signal is a pulse center to edge modulation. On this slide, this shows the video time lapse of doing the circuit on LT Spice. On this slide, this shows the phone recording on doing the PWM circuit. Thank you for watching this presentation.